going to discuss about cross-site scripting attack. First of all, we're going to see the definition of cross-site scripting attack. Cross-site scripting attack is often abbreviated as XSS, is a type of attack in which malicious scripts are injected into websites and web applications for the purpose of running on the end user's device. During this process, unsanitized or unvalidated inputs, which we can say user entered data, are used to change outputs. Some XSS attacks do not have a specific target. The attacker simply exploits a vulnerability in the application or site, taking advantage of anyone unlucky enough to fall victim. But in many cases, XSS is performed in a more direct way, such as in an email message. An XSS attack can turn a web application or website into a vector for delivering malicious scripts to the web browsers of unsuspecting victims. Types of cross-site scripting attacks. Most XSS attacks can be divided into three categories: reflected, stored, and DOM-based XSS. Reflected is also known as non-persistent and stored is known as persistent. Reflected or non-persistent XSS. In reflected XSS, the attack vector is inside the HTTP client request processed by the server. If the server's request and response are semantically related, the server's response is formed from the request data. For example, the request could be a search query and the response might be the results page. Reflected XSS occurs if the server does a poor job of processing HTML escape sequences. In this case, the page as displayed on the server side will cause JavaScript to be executed in the context of the server, which is the part of original attack vector. Here is an example of reflected XSS. The attack is performed on a dummy website known as damn vulnerable web application. Here the script is submitted in the search bar and it gets executed and gives an alert that the system is hacked, which is a fake alert. Now the stored XSS. This type of application vulnerability occurs when an attack vector contains JavaScript that doesn't come in a user request. Instead, the JavaScript code is downloaded from the server, such as the database or file system. The application might allow you to save data from an untrusted source and subsequently use this data to generate a server response to a client's request. Paired with poor handling of HTML escape sequences, this presents an opportunity for a stored XSS attack. Imagine an online forum where people communicate regularly. If the application is vulnerable, an attacker can post a message with embedded JavaScript, the message which will be saved in the system database. After that, the script in question will be executed by all users who read the message posted by the attacker. Now, the example of stored XSS. The same dummy website DVWA is used for the stored XSS attack, but the only change is that now the widget where the attack is performed is a message box. As the messages written by the users are stored in the database, the malicious script written in the message box will also be stored in the database permanently, and whenever someone tries to visit this website and at the backend on the server side, the malicious script will run and get executed and can cause the harm to the client. DOM-based attacks. The two types of XSS vulnerability described before have something in common, and that common thing is that the web pages with embedded JavaScript is formed on the server side. However, the client frameworks used in modern web applications allow changing a web page without accessing the server. The document object model can be modified directly on the client side. The main premises behind this vulnerability remains the same, specifically poorly implemented processing of HTML escape sequences. This leads to attacker-controlled JavaScript code appearing in the text of a web page. That this code is executed in the server context. DOM-based attacks are very rare, but reflected and stored XSS attacks are very common. DOM-based attacks are mainly used to deface the websites and harm the reputation of the website owner. Now we'll see some attacks performed on the dummy website. To perform XSS or cross-site scripting attacks, we will use OWASP, which is a open web security project broken web application. It is a specifically designed or purposefully designed project to show developers about various vulnerabilities which can be present in a web application and how these vulnerabilities can affect the website, as these vulnerabilities can be used by attackers to perform malicious attacks on the website, such as injecting scripts and SQL injections. For this, we have to start our OWASP server in the virtual box and have to log in on the server to get access to the broken web applications which are present on this server. There are various web applications which are present, and these web applications are all full of vulnerabilities. Any web application can be used to perform hand-on practice to perform various attacks and check how these vulnerabilities actually work. So we have to log in. The login credentials are root and password is OWASP PW. We have successfully logged in, and it is shown that now we can access the web apps at the IP address 192.168.1.10. We have to open our web browser and go to the 192.168.1.10 IP address. Under this, these are all the various websites, broken web applications actually, which are present, and we will for this demonstration we will use damn vulnerable web application. For this, we have to log in, and the credentials are admin as username and password is admin as well. Logging in, under the various options we will choose XSS reflective. If we give a valid input, as it is asking for a name, if we give a valid input which is a name and submits, it just gives a message of hello and the name. But if we run a malicious script, but here it is not malicious, it's just an alert box to check if this web application is in fact a XSS reflected vulnerable website or not, and is it executing the scripts and in the server side. So when we submit, we see that in fact the alert box is being displayed, which shows that it is an XSS reflected vulnerable website. Similarly, for XSS stored, first we will try to give the valid inputs, which is a name and a message. We see that the valid inputs are being stored, name and message is being stored on the database. Similarly, if we try and test that is it storing a script in the database or not, again we are using just alert script for the sake of demonstration to check whether the website is XSS stored vulnerable or not, and signing in. Now we can see that it is in fact XSS stored vulnerable, as the script is stored on the database. Now if we use this link and tries to open a tab, see it is again running the script which we stored earlier in the database, as it is stored in the database permanently. So whenever anyone tries to visit this website or uses this link to access this website, the script will run and the backend. If it is malicious, then it can harm the client as well as the web application, and much more malicious things can be done through the cross-site scripting attack. So that's it for the demonstration of cross-site scripting attack.